question number 2 for review for exam 3 is similar to question number 1, but here we have 3 different summations. We want to rewrite the expression using a single power series whose general term involves x to the k. Okay, so there are 3 rules for combining summations. The first rule involves if you have any x's outside of the summation, you bring them in. So I'm just going to say first rule is to combine all powers of x. So I'll say within each term. We don't need to do that here. And then 2 is we need that common x to the k. So the variable can really be anything that you want it to be, but it needs to be consistent. And so here we're going to take each one of these exponents, x to whatever power we have, and we're going to replace that exponent with k. On this first summation term, we're going to let k equal n minus 2, and then n is going to be k plus 2. I just write that down to make the substitution a little bit easier. And then, excuse me, I wanted that to be blue. We get k equals, let's see, n starts with 2. So k is going to start with 2 take away 2, or 0, to infinity, and then I have n, which is k plus 2, and then I have n minus 1, which is k plus 2 minus 1, which would be k plus 1, and then c sub n, which is k plus 2, and then x to the k. And then let's see, on my second term, and on my third term, we just have n for the exponent. So that n just gets replaced with k for both of those terms. And so I'll just rewrite those using k there. And then our third rule involves a lower index. Notice that our lower indices are at k equals 0, k equals 1, and k equals 0. We need to have a common lower index. Okay, and because we have different lower indices, we'll want to rewrite these summations by removing terms, and we always want to expand to the higher term. So here where I have k equals 0, I'm going to remove one term. If I remove the k equals 0 term from the summation, then I can rewrite the remaining terms as the sum as k goes from 1 to infinity. And it will match my indices for my second summation. So for that last summation too, we need to remove the k equals 0 term. So I'll rewrite this, and my k equals 0 term, I'll highlight it here so that it's easy for me to pick up later. K equals 0 term, when k is 0, this becomes 2. times 1 times c sub 2, and I'll put x to the 0, and I know that just means that this is a constant term. And then the remainder of my terms can be written as a single summation, now with a lower index of 1. K equals 1 to infinity. The actual expression inside the summation does not change. My second summation just gets copied. And for that third summation, see if I have more space. I think I have enough. If I remove that k equals 0 term, that's going to give me c sub 0 x to the 0. And then I have a summation. K goes from 1 to infinity, c sub k x to the k. So now that I have this x to the k in common, now that I have a common lower index, I can combine my summations together. So I do have these terms outside of the summation that I need to deal with. Scroll up just a little bit. And so I'll copy these first. That first term is just 2c2, and the second term is just c0. And then when I combine the summations, I'll have the sum as k goes from 1 to infinity, and all of these summations will have a common x to the k. I'll factor out that x to the k, and then write what I have left. I have k plus 2 times k plus 1, c sub k plus 2 from the first summation. I have minus 9 times k c sub k from the second summation, and I have a plus ck from the third summation. And there I have everything combined into a single summation with that common x to the k term. So this is a good answer. You might notice that those last two terms have a c sub k in common. This term here does not. So if you wanted to, you don't have to now, but if you wanted to, you could factor out that c sub k, and that last term would be negative 9k plus 1 times c sub k. And then everything else would stay the same. So either one of those answers works. You might group these terms inside its own group, the terms that are outside the summation. So there's number 2 from the review.